Good evening. Tonight I'm starting a new series entitled Quality Tools, and I'm going to start the series by talking about one of the most important quality tools, which is called the control chart. Now, in total, there are 7 different quality tools. The control chart is certainly one of the most important. Now, you'll hear different names for this. Sometimes, or it's called the SPC chart. You'll hear terms like run chart, process control chart. These are all subtle variations of the same thing. They're definitely related terms. I'm going to start by just talking generically about a control chart, and then we'll dig into some of the differences between those terms. So what I've developed here for you first is just a framework. I just built this in Excel, a grid, and this grid is sometimes called a run chart. Okay, I'm going to just throw this up here, run chart. Simply, I missed an A there. Simply is the foundation for a control chart. So run charts or control charts record process information over time. So for instance, let's say I am working in a manufacturing plant and I'm working an 8-hour shift. The control plan that I'm using, the quality control plan that I'm using, might specify that every hour of my shift, I'm there for 8 hours, every hour of my shift I grab 3 samples. I grab 3 samples every hour and I measure them for some characteristic. And the vertical axis is the plot of that characteristic. Now, for instance, I'll just use an example. I worked in a heat treating application once, steel processing heat treating. We checked the hardness of the samples going through the heat treating operation, and the specification in that application I'm thinking of was 88. So this is the customer's specification, 88 plus or minus 5 points, and the scale, it's called HRB. If you're familiar with hot rolled bar or heat treating processes like normalizing, spheroidized annealing, things like that, you'll be familiar with this scale, HRB. It's for moderately hard steels. So this HRB is just a scale, and here's the specification, 88 plus or minus 5 points on this scale, and there's specialized equipment for taking those measurements. So our control plan specified this 3 samples per hour. Okay, so before we even get into the data, and this is my data over here, I know that 88 is my, we could call it my target, or the nominal value of the specification. Okay, and then it's plus or minus 5, so 89, 90, 91, 92, 93. Okay, so there's 93. And minus 5 would be 83. 1, 2, 3, 4, 5. Okay, so the specification range is 83 to 93. Now this 93 would be called the upper specification limit, and the 83 is the lower specification limit. USL, LSL, those are very common abbreviations used throughout industry. So these represent our specification limit. So another characteristic of our run chart or control chart is going to be just a marking of that. So I'm going to put that red line there. That's our upper. This is our lower specification. So if our process is in spec, all of our values are going to fall on this chart between these 2 lines. Okay, so what I've done over here is I've plotted some data off in Excel, and I'm just imagining this is my process data. Okay, so it says I collect 3 parts per hour. I have 5 hours worth of data here, and here's my 3 samples. I might call this X1, X2, and X3. Okay, those are my samples. It says 3 samples per hour. Let me change my pen color here. Sometimes you'll see on control charts, things like that, it'll say N equals 3. N just means the sample size. Okay, so n is our sample size. So here's my data over here. And what I've done ahead of time is I've taken the arithmetic average, just the average. So I've added these 3 in this case, divided by 3, and these are my values. So here's my individual values, 88.3, 88.5, 88.7 in my first hour. So the average is 88.5. These terms right here are commonly referred to as X bar. That bar indicates the average. So this is a run chart, and we're going to be plotting the X bar values. So sometimes you'll hear this term called an X bar chart, and that's exactly what we're doing here. This is an X bar chart. We're going to talk about other run charts, other types of control charts. This one, we're plotting the X bar, and it's a very common plot, so that's why sometimes you'll just hear that phrase X bar chart. It's just another way of describing the same thing. Okay, so what we're going to do on here, and again, we're plotting our, this is just a run chart right now. We haven't gotten any control yet, but we're going to plot our values every hour. So in our first hour, our X bar was 88.5. Put a little point there. Second hour, 86.3. What the heck did I just do? 86.3 is down here. How about that? That looks better. Okay, there we go. 86.3. Hour 3, 84.7. So here's my hour 3, 84.7. Hour 4, 85. 459 right there, 85.9. And then my fifth hour, 87.2, so I'm up over here. Okay, and obviously as my shift goes on and then the next shift comes in other words, as the process continues, the data just fills in. Okay, so the first thing we're going to do is to connect these points, and by connecting them, before you do any analysis, you're already getting a graphical representation of the points. Okay, so without even any statistical analysis, I'm just looking at these and I'm saying to myself, okay, the data, the process data, is running in the lower half, basically the lower half or the lower side of the specification range. That's significant. That might mean something to us later. It's within specification, so my upper and lower specs are outside of the data. And as I glance at this, my low number here, let's see, 84.7 to my high side, 88. They're about a 4-point range. My specification has a 10-point range. So far, my process data has a 4-point range. So all that is going to be significant as we begin to develop the control chart and then analyze the data. So to put it kind of simply, a control chart is really a run chart plus statistics. Okay, so it's a run chart, which we have here, which is a plot of the data and specifications over time. And then we're going to calculate some stuff, run some statistics, and we're going to add some other features to this. Those features are called control limits, are going to tell us a little bit about this process and how it's running. So we're going to continue this in the next part and pick up on turning this run chart into a control chart.